The first thing I want to talk about is a concept known in programming as scope. And this scope is something that we've actually come across already in our programming. But I wanted to leave it until we've seen functions, we've seen if and while loops, different types and blocks of code before we start talking about this really important concept. Now, if you want to visualize this concept, imagine you have a house with a fence around it and you plant an apple tree inside your garden. Think about who can access those apples. Just you and your family, right? But what if instead you had an apple tree in the neighborhood, by the sidewalk, for example? Well, this is kind of free for all. Anybody can go and access those apples. This is a starting point for how to understand scope. Head over to the AppRury Day 12 Start Replit and go ahead and fork your own copy of it. Take a look at the code that's in the starting file in the main.py and try to understand what it's doing. First, I create a variable called enemies and I set it to equal 1. Then I create a function called increaseEnemies and I try to set that variable to 2. Finally, I call my function, triggering all the lines of code inside. And now I want you to predict, what will this print statement print in the console and what will this print statement print? And it might not be what you expect it to be. So I would expect that here I've got a variable which is equal to 1. When this function is called, this variable enemies should now be equal to 2. So when it's printed down here from outside my function, this should be equal to 2 and this should also be equal to 2. But look at what happens instead. I get enemies from inside the function equal to 2, but from the outside the function it's equal to 1. So what's going on here? To really understand this, we have to understand the concept of scope. And scope is a really, really important thing in programming. You see it in every programming language. And although it's a little bit different between the programming languages, it all goes back to that concept of the apple tree being within a fence or outside a fence. So let's take a look at some other examples before we come back to solve this problem. The first thing to think about is a concept called local scope. Local scope exists within functions. So for example, if I was creating a game and I had a function called drink potion, which is somehow going to strengthen my player, well, maybe it would have a variable that's created inside the function. So it could be something like potion strength, and I could set that to start off with a value of 2. Now, in this case, if I was to go and print this variable potion strength from within the function, notice I'm indented here. And of course, I need to call this function for that to happen. Notice what happens when I run the code. It's equal to 2. That's what we would expect, right? But notice what happens if I try to print the potion strength from outside the function, here. This firstly gives me an error right when I'm writing it inside the editor. And when I try to run it, it gives me an error inside the console. And the error is a name error. And it tells me that the name potion strength is not defined. Clearly, I've defined it here, but why can't I access it outside the function? Well, this goes back to the concept of local scope. When you create a new variable, or indeed a new function, inside another function, it's only accessible. You can only use it when you're inside that function because it has local scope. It's only valid within the walls of this drink potion function. What if we wanted it to be accessible outside the function? Well, now we need to think about something called global scope. The only difference between global scope and local scope is where you define or where you create your variables or your functions. So let's say we have a different variable. Let's say that I created a variable called player health and it starts off being equal to 10. Now let's say later on I have the same drink potion function and this potion has strength of 2. So now inside my function drink potion, if I wanted to print my player health, even though it wasn't defined within the function, this is perfectly possible. And if I call my function drink potion and then run the code as it is, you'll see 10 being printed. So this has a global scope. It's available anywhere within our file because it was defined at the top level of the file. Now, when I say top level, I don't mean physically at the very top of the file. I mean that it's not within another function, like potion strength here, because this is defined indented inside a function. So this is a local variable, whereas this is a global variable. And global variables are available within functions, no matter how deep it gets nested, and it's also available outside of functions. This concept of global and local scope doesn't just apply to variables. As I alluded to before, it also applies to functions and basically anything else you name. This is a concept called the namespace. So we defined this variable player health. We defined this function drink potion. Anything that you give a name to has a namespace. And that namespace is valid in certain scopes. This concept of scope applies to basically anything you name. If I was to nest this function drink potion inside another function, let's call it game, well, this drink potion now has local scope within the function of game. So this is why this line is now erroring out, because it can't actually see inside this function. So now, in order to call this drink potion, I have to be within the 4 walls of the game function. So whenever you give name to anything, a function or a variable, you have to be aware of where you created it. Now, it's easy to notice where you've created functions. We have the def keyword, right? But when you create a variable, that's the first time that you give it a name and you set it equal to something. And where you write that line of code defines the scope of that particular variable. Here, it's outside of every other function, whereas here, it's inside a function actually nested 2 levels deep, so it has local scope to this function. Now, unlike some other programming languages, if you've come from, say, C++ or Java, there is no such thing as block scope in Python. What this means is that if you were to create an if statement, say if 3 is greater than 2, and if you were to create a new variable inside an if block or a while loop or a for loop, basically any sort of block of code that's indented, this does not count as a fence. It still has the same scope as its enclosing function, or if there's no enclosing function, then it has global scope. So let me show you a full example. Let's say we had a list of enemies. So the enemies could be skeletons, zombies, or aliens. So now if I was to define a game level, right, like the level that the user is currently playing at, let's say they're on level 3. And I create an if statement and I check if the game level is less than level 5. Well, in that case, I want to create a new enemy, but I don't want the enemy to be too difficult to beat. So I'm going to pick from the list of enemies and I'm going to pick the first one. Notice how even though this new enemy is a variable that's created within this if block, if I go outside the if block, so I'm not indented at all anymore, and I try to print this new enemy, this is perfectly valid code. And if I run the code, you'll see skeleton being printed. But notice how as soon as I embed this within a function, so let's define a new function, and now this line errors out. Because within the function there is local scope, so now this new enemy is available anywhere within this function because blocks like if, while, for, all of these blocks of code with colons and indentation, they don't count as creating a local scope. So in order to print this new enemy, I actually have to be within the boundary of this function, which means my code has to be here. The most important thing to remember from this is if you create a variable within a function, then it's only available within that function. But if you create a variable within an if block or a while loop or a for loop or anything that has the indentation and the colon, then that does not count as creating a separate local scope. Coming back to our original example, I want to talk more about the global scope and the concept of modifying something within the global scope. Here we have enemies, which is a variable that has global scope. And here we have a function which creates a local scope. Now we think that we're tapping into this variable and setting it to 2. But in fact, we're actually creating a completely new variable that's entirely separate from this one. And this is why when we printed it here, it showed it was equal to 2. But when we printed it here, it showed it was actually equal to 1. If you want to make this a little bit more obvious, I can call this a skeleton and I can set this to be a zombie. And when I hit run, you can see again, this prints zombie, this prints skeleton, because these two variables are actually entirely different things. And we're not changing this right here at all. We're just creating a new variable that has a local scope. Now, it's usually a terrible idea to call your local variables and your global variables the same name. But in this case, what we actually wanted to do was we wanted to modify this variable. We wanted to do something like maybe plus equals 1. And notice how as soon as I write plus equals 1, then my editor starts going crazy and tells me that this local variable enemies is defined in an enclosing scope, is referenced before assignment. What does that mean? It means that the editor thinks you're trying to tap into a local variable that you defined somewhere around here. And then you tried to modify it by adding 1 to the previous value, but you actually haven't defined it. What we wanted to do though is we wanted to tap into this variable and change it here. In order to do this, we actually have to explicitly say that we have a global variable which is called enemies that's defined somewhere outside of this function. And that is the enemies that we want to use inside this function. So it basically takes that global enemies into the function and allows you to modify it. Without this line of code, we cannot modify something that is global within a local scope. Now, there's a reason why it's so difficult to modify something that has global scope. You probably don't actually want to do this very often because it's confusing and it's prone to creating bugs and errors. Because this variable with global scope could have been created anywhere in your code, right? And you would be modifying it completely independent of when you created it. So it might have been days between when you wrote this code and when you wrote this code, and it just makes everything more fallible, more easy to fail. This is why very often people will tell you when they're teaching you Python to avoid modifying global scope. You can read it, that's not a problem. You can use it within your code like we are here, but don't try to modify it within a function that has local scope. But what can you do instead? What if you wanted to have this functionality, like a function that changes the number of enemies? How can you achieve this without modifying the global scope within the function? Well, you could use what we learned about return statements instead, right? What if instead of modifying the enemies, you actually just simply returned it as the output? So return the current value of enemies plus 1. Now, once you call this function, you'll get hold of the outputs and you can save it to the global variable enemies. So this now means that this function can be taken away and placed anywhere in your code, and you don't actually need to know how it works. As long as you know that this is how you increase enemies, then all you have to do is just call it. Remember, you should be careful with variables that have global scope, but don't believe the people who tell you that you should never use global scope. Global scope can be incredibly useful, especially when you're defining constants. Global constants are variables which you define and you're never planning on changing it ever again. It's just something like, for example, the value of pi, right? You want to look it up once and you want to put it into your code and you never want to look it up ever again. And every other time you want to use it, say inside a function, then all you want to do is just tap into that value of pi. So usually, in order to differentiate these constants, which you're pretty much never going to change, from the variables, which you're likely to change, the naming convention in Python is to turn it into all uppercase. For example, if you had pi or you had a URL that you needed to use, or you have some sort of Twitter handle, then these are all going to be uppercased, separated with underscores. What this means is that later on in your function, and you want to use one of these global constants, as soon as you type it, you can see it's uppercase and you know to remind yourself to not modify this inside your code. Now that we've talked a little bit about scope, it's time to put your knowledge into action. Head over to the next lesson, and I've got a quiz that will test your understanding. So for all of that and more, I'll see you there. Now that you've completed some of the scoping problems, it's time to tackle the final project. This final project is a little bit special because now I think you've got enough experience and enough skills under your belt to actually create this project entirely from scratch by yourself. So you're flying solo now. Now, the first thing I want you to do is head over to guessthenumberfinal.appary.repl.run, and I want you to play this game quite a few times actually, just so that you get a good idea of how it works. Now, the first thing it tells us is welcome, and then it tells us it's thinking of a number between 1 and 100, and then we get to choose a difficulty. So I'm going to choose hard. Now it tells me that I have 5 attempts to guess the number, and I'm going to make a guess. Now it tells me that 50 is too high. It's not the number that it was thinking, and I have to guess again. And notice how I started out with 5 attempts. I'm now down to 4 attempts. So let's try 25. So 25 is too low, but 50 is too high. So that means the number is somewhere in between there. Let's try 30. Again, too low. Let's try 40. Too high. Maybe it's 45. But I only have 1 attempt left because I went for the hard level. And as expected, I didn't manage to get the right number, and I've now run out of guesses. So I've lost. If we run again, we can try playing this on an easy level. On an easy level, we get 10 attempts instead of 5. That gives us a little bit of extra opportunity. So let's try 50. 50 is too high. 25 is too high. 10? 10 is too low. So it's between 10 and 25. So let's try 15. Now, if 15 is too high but 10 is too low, then we're pretty close to the answer. It's now between 12 and 15. Let's try 13, 14. There we go. The actual answer that it had in mind was 14. And I had 4 attempts remaining to get the final answer, and I managed to get it at the end. Play through this game at least 3-4 times on the different levels. And remember that the easy level has 5 goes. The hard level, the user gets 10 goes at guessing the number. And look at how the code works and how it's functioning. And then I want you to break down this problem. write a to-do list, create your own list of tasks that you need to solve, and start with the simplest one. And once you've tackled that, start putting in some comments into your code. Write down the functionality your program needs, and then write the code. And then test out your code and keep going until you've tested it and made sure that it works in all situations. So this final project has no starting code. I'm not going to give you any comments or to-dos to start off with. I want you to try and tackle this entire project by yourself. And the only thing I'm going to give you is this link so that you can try out the final project. And I know that there's a lot of ways that you can cheat, but don't do it. Have faith in yourself. If you tackle this for an hour, I'm pretty sure you're going to get there in the end. You have free reign on the styling or the wording, whatever it is you want it to say, but it has to have the same functionality. Now, this also means that if you want to get some ASCII art of your own, then you can head over to this website, which I'll link to in the course resources, and just type the name of your game. So maybe it'll be guess the number. And you can change the font that you want for it. Maybe something a little bit isometric, or maybe ogre, or maybe train, whatever it is you want. And then once you're happy with the font, you can select and copy everything that's on there. And then inside your project, you can create a new file called art.py and then create a new variable and set it equal to the design that you've got in mind. Now, in order for it to look right, you actually have to create this as a docstring. So 3 quotation marks to begin with, and then 3 quotation marks to end. And then just make sure you have enough horizontal space to display the whole thing in one go instead of it being truncated when you have a little bit of space, and you should be able to see the actual design. Pause the video now and create this number guessing game by yourself as the final project.